Everybody. This is the Tech Talk session on a slimmer, thinner, lightweight OpenStack, why it is needed for the success of Edge Cloud. And I'm Hasib Akhtar from Ericsson.
First of all, thank you guys for coming. It's too late in the evening with most of the people travel from US, like suffering from jet lag. Thanks for coming. This is Kandan Kadrivel, Director responsible for Cloud Strategy and Architecture.
My name is Christopher Price. I work with Ericsson in our Ericsson Software Technology division. Again, I'd like to say thanks for coming. We'll try and keep you awake for the next 40 minutes. And Hasib, back to you to kick us off.
Thank you, guys. So we have been discussing Edge quite a bit in this summit. So I'm going to start on some of the innovations that telco industry has been going through lately. So one of them is, of course, in the area of radio access technology. We have managed to virtualize a few components of it. We have made it more flexible to basically deploy different parts of the RAN or some of the key parts of the RAN and the core network closer to the edge or even distribute across the network. But above all, there has been quite a few innovations that has happened across this industry. We have distributed a scalable cloud in many deployments. Our colleague Kandan in AT&T have deployed a very large-scale distributed cloud. I've mentioned about some of the RAN features that are already virtualized and can be deployed in the access sites. And then, of course, there are a lot of applications that have come forward and still upcoming that can also be deployed at the edge. So all of these innovations actually be very much accelerated by the realization of the edge cloud. So in essence, a lot of this innovation is very much dependent on the users using the edge cloud or the edge computing technologies. Moving forward, in terms of the VNFs that will be coming to the edge, from the RAN components, there will be the disaggregated RAN part, what we call RAN central unit, and of course some of the core networks. Those VNFs would be now available to be deployed at the edge. And because of that, it opens up an opportunities for other applications, such as the MTC, a lot of the IoT-related applications, analytics, content, TV media, and of course, much talked AR, VR type of applications. So those are some of the VNFs that would be in the edge that can be containerized or virtualized. And then there will be some portion of the RAN will still be on the purpose-built hardware, but that will not inhibit in any shape or form the advancement of the edge cloud and the edge computing. So to describe how it all will fit in and how things will basically be realizable in terms of the software infrastructure as well as the whole realization of the edge cloud, I'll now leave it to Kandan to take you through that journey.
Next slide, please. So the question really comes into the mind when we talk about edge computing is really twofold. And this has been really discussed in many forums within OpenStack in this conference and even before in the previous conferences. It's really come down to is like, do we really need OpenStack to support edge computing? And if we do, why? Those are the two main questions currently being asked with respect to the edge computing. So this particular slide, if you look at it, it explains in terms of, why do we need edge computing? So when we look at on the top of the slide, so we talk about, how many milliseconds it takes in processing in the device, then it processing in the, customer premise equipments, then in the access layer, then in the computing layer, if we do it in the centralized cloud, or just we do it on the edge computing, which is actually closer to the user. If we do all this processing in the centralized cloud, the way we do it today, what will happen is that it will be beyond 20 milliseconds. And with that, beyond 20 milliseconds, the application which are really coming up in the industry today, for example, augmented reality, virtual reality, and we take drones, this quickly requires processing closer to the edge. And it has to be less than 20 milliseconds. So if we take AR, VR equipments, they need within 20 milliseconds of response time from the whole compute processing, the data transfer in the wire to support that application. So this is a key part that we need to understand. So this 20 millisecond really means that just for AR, VR, we really have to have this cloud deployed closer to the user. When we try to deploy this closer to the user, the problem that we did not see in the centralized cloud, we will start seeing it in the way the edge cloud need to be deployed. So in the centralized cloud, the scale numbers, we really talked about, like 10 location or hundreds of location. It is not deployed in the scale of like thousands or millions of location. More we go closer to the user, the number of location is really going to go high. So in this picture, if you see that, if we go closer to the user, we're talking about millions of location. So edge computing, in order to meet this particular latency number, we really need to be, getting closer to the user, but also it really come down to is like, do we really need to deploy millions of location? We don't need to deploy in millions of location, but at least it has to be in the range of thousands to really support this 20 millisecond latency need. So now the question is like, is OpenStack ready to deploy this in this many number of locations? That's what we're going to see in the next couple of slides, and talk about what we have in OpenStack as of today, and how we are deploying the OpenStack today in the data center, and what is this additional requirement of deploying in thousands of locations, the requirement-wise that OpenStack really need to support. That's what we really want to talk in next couple of slides. Next slide, please. So when we look at this architecture picture, I call this as like edge optimized stack. So it really comes down to 2 points. Do we really need to support virtual machines in the edge computing? The answer is yes. The question is like, why can't we just do everything as a container and microservices? We do like to do everything as a container and microservices, but there are set of applications which are not ready to support microservices and container. I'll give you an example. When the virtual network function came in and transformed the physical network functions of telco and put everything into a virtualized deployment, that's where OpenStack comes into place of orchestrating the whole suite of virtual network function. The key part is that the code itself is transformed into a monolithic, most of the VNF, they are transformed as a monolithic components. It is not really supporting a microservices. So it is really, the industry is going to take at least the next couple of years to really move into a full-fledged container and supporting microservices in the virtual network function. But the edge computing cannot wait for another 4 or 5 years or 2 years to really support these virtual network functions at the edge, as well as like the applications really need to be enabled. If we do need to enable this edge computing application, the infrastructure itself need to be also virtualized. And that's where the question really comes down, is that we really need to support both VM and container. So from a container context, we can run containers using Kubernetes and other ways of doing it, but Kubernetes is the preferred way. That's what we think. And then we have a virtual machine. So in order to have the virtual machine orchestrated, the one thing we all hear is OpenStack. So now the question is that we saw that additional requirement that, because of the scale, that's going to bring up like additional requirement, which we never addressed in the data center-based deployment. So the thing is like the design, the build, and operate. it need more zero-touch provisioning compared to the data center in the edge computing so that we can address the scale. But it also brings up a question, do we really need to build entirely a different tool stack and differently, like software to deploy one way in the data center, in another way in the edge computing? The answer is no. The reason is that we don't want to actually maintain like two different stack of software and tool set, but we do really need to address some prescriptive number of configuration in the edge computing so that we can actually deploy this in the edge. So we can use OpenStack, but the context is that we really need to address some of this, the requirements, especially like finite set of configuration, completely zero-touch provisioning, and addressing this number of location, like 10,000 plus location deployment. So these are the items that definitely is a key. Then it really comes down to is like, how do we run the OpenStack? So the methodology that we've been adopted, and we are pushing the community in, and OpenStack Helm is really coming up very nicely. And deploying the container, not only for the application, but also running the OpenStack as a container would help us in putting the OpenStack in a smaller scale deployment, especially at the edge. That helps a lot with respect to like how do we package it up and how do we actually support this in the data center deployment versus like edge computing deployment. Next slide, please. So the question is like we talked about container Kubernetes, then we talked about OpenStack. Is that good enough to really support the whole implementation of the edge computing? Because the solution is really coming from a different open sources now. There is not really a one open source, It is not just OpenStack. Then we got like some SDN solution coming from another open source. Then we got orchestration like ONAP. Then we got like, cloud native applications like Kubernetes. So the open source field is actually, like there's many open sources. The key is that not the innovation, it's really the integration. If we don't integrate all this thing in the community itself, then what happens is that, like the vendors, they have to take it and create a distro. So in that case, what happens is that not all permutations of configuration is really being tested. And then the VNF and applications, like they don't really test everything. Then it really comes down to the providers or the user, and they feel the pain point of, like integrating everything, and it takes a long time in integrating it because there's so many open sources. Then what happens is that, like it doesn't meet the business timeline. Then it impacts the overall, like the health of the user as well as health of the community, because users will definitely lose interest in the open source community if the end-to-end integration doesn't work. And now this is even actually applicable in the data center deployment today. And this also brings up like additional challenges in the edge computing. We talked about large scale, we talked about simplified operation, we talked about low cost, because I can't have the same cost which I used to deploy in the data center in the edge. The reason is that we're really talking about numerous locations now. And also multiple edge use cases. It is not just about AR, VR. There is a 5G application, which is the infrastructure itself. Then there is IoT. So there is a multiple use cases coming down. So there is a complexity of things actually also coming from the edge. So what do we really need from the community perspective? The user experience is definitely a key, because if a user cannot download a software and install it and then like maintain it, then it is very hard to deploy this many number of locations and maintain it and put the contribution back into the community. The end-to-end stack, I think, again, this is the key, is that the community itself, if it hosts everything end-to-end stack, then it is easy for the community to collaborate and innovate fast, and also makes the user very happier. And the other aspect is like production-ready code, right? Some of the things comes out of the community. What happens is that it's mostly a development or research-based code, not sometimes it's a production-ready code. Especially when we integrate, it is not fully production-ready code. So if we don't have a production-ready code, then the work happens after the fact of it's coming out of the community, then it delays the whole thing, right? So definitely there need to be a vendor ecosystem, and also faster innovation has to be there. But the key is actually the end-to-end integration. So in this slide, I talk about what does this really mean from a community approach, right? So this is sort of my thought process and our thought process, and this is what like many people in the community are sharing. So we talked about, like the items across like multiple things, coming from OpenStack, coming from ONAP, coming from Cloud Native Foundation, and all these things are coming along. And we need to take everything and build this edge end-to-end solution. So what does this really mean is that we really need to have a glue, which actually connects everything together and integrate together in the community itself, and develop additional features. And the key is actually that we don't want to fork the existing open source communities completely. The original, whatever the additional development happening in this edge stack has to go back into the original community also. The full life cycle of the CI/CD need to be taken care, because if it is not, then it is not really a fully integrated solution. And another key is that it has to be demonstrated with end-to-end use case, because sometimes what happens is that the open source communities, they develop the code, but they never test it with for example, if there is an IoT application that Edge has to support, and developers develop in the community, okay, here is how this is going to be supported. But if they never tested that with respect to that IoT application itself, what happens is that the complete solution doesn't work. So we really have to make sure that community is not only just addressing the code, but also the end-to-end use cases. And then, like vendors can actually take this and, like they can further harden it and give it to the provider. So this model of, like keeping an end-to-end solution in the community would help not only the user, but also it will help to actually keep up the community in terms of the solution. So Open Dev Conference, many of you guys actually joined that conference. And what happened in the Open Dev Conference is that there's a lot of good discussion about Edge, right? It was a focused discussion. People came across the world, talk about, like kicking start the Edge discussion, right? So we talked about what are the Edge use cases and what are the prototypes that everybody is doing. Because there's so many prototypes, it's very interesting to see that, like everybody is doing something along it, but there's not really coming together as a community. So this Open Dev Conference definitely helped in bringing the people together and showcasing their own prototype and trying to find a commonality that people can agree as in a reference architecture, what I was showing on the before, and then supporting that in the community. The another key part is like a documentation of the use cases. And that is very important, because when we talk about like multiple use cases, IoT, 5G, the expertise is coming from a different industry, and they all coming together and documenting in a use case that development people in the community can develop to it. And also the gap analysis across the OpenStack, right? So that is a key, right? I talked about large scale. I talked about like a zero-touch provisioning. So these use cases were being documented, and it is actually in that OpenDev website itself. I think it's all come down to the question that I was asking in the beginning of the talk, is that are we ready to support OpenStack in the edge computing deployment? The answer is that it is possible to put it in a container and run it in the container on edge computing as of today. It is possible, and we already trying that. One of the key part that we have to keep in mind is that we still need to slim this down and make it more lightweight, so that like it can actually deploy it in large scale deployment. Again, the emphasis I would do is like a fully integrated solution. That is very, very important in terms of community addressing this, because this is not just OpenStack. This is not just container. Now we're talking about multiple communities, multiple software. If there is no end-to-end thing, then there is not really an edge stack.
Does Taka and glue-on not suffice?
Let us finish the thing, and then we can come for the question. Go ahead.
Okay, Chris.
Good. Okay, so I want to talk a little bit about the industrial landscape as it stands, or more the open source landscape as it stands. Haseeb talked about innovation in RAN at the edge. He talked about the fact that peripheral or remote devices are going to have both embedded and hosted softwares. It's not just going to be a cloud. Haseeb talked about the challenges of operations, how it looks when you start to scale out, what we need, how we need to approach building the distribution when we come to handling 1,000 small sites where we don't want to be interacting with that software. We need that software to be lightweight, manageable, and more or less easy to use and transparent to the operator. I wanted to talk a little bit about how does this all fit together? We say these things from a telco perspective, and unfortunately we're telco guys, so we know exactly what we're talking about. Not everyone else does, and so you see a requirement coming and don't really understand it or don't understand why it's coming from us. I wanted to swap that around a little bit and come back to some basics and then put that in the context of the conversation we've just had. So the basic paradigm I'll work on here is infrastructure, platform, and application. Infrastructure, regardless of if it's a large data center or if it's a distributed cloud or it's an edge cloud, we need it to be standard, we need it to be flexible, and we need it to be ubiquitous. It needs to be where it needs to be. We don't want a lot of specialty hardware that we have to deal with. We don't want a lot of specialty APIs. We really want something that we can trust and we can build on top of. Platforms then generally address a target technology. They're generally optimized for that target technology, and they're scalable. They bring the ability to take that technology to scale in the domain that they're dealing with. And then applications, of course, provide a product or a service on top of that. They leverage the capabilities that are provided in the platform. And if we have a look at where we stand today, on the infrastructure side, Open Compute, Open 19, and then 1,000 more. I mean, I won't go into all the different hardware types, but there is a general approach to how we can approach hardware expanding in the industry today. From there, you have groups like ETSI, groups like 3GPP, and they're starting to standardize, okay, how do the peripheral components work? How do these use cases get realized? How does that infrastructure actually look? What are the APIs? What are the interfaces? How is it gonna work? But we're still talking about things like how my phone connects to the network itself. It's not like we have applications or services that we're applying at this level. Very much infrastructure related. You move from infrastructure into platform, and then you start to talk about things in the distributed cloud world like OpenFog. How do we describe and construct software that can run in these devices? You talk about things like cloud native. How do we work with containers? How do we establish service meshes that allow us then to scale across multiple sites and manage our applications in a useful way? You start to move even higher up the stack into serverless architectures where you start to look at just running functions through a service mesh within an executing operating system. And these provide really platforms. And the ones I've highlighted here are very much general purpose platforms. They're still opinionated about what's happening there. I mean, you're still going to be running in the environment that platform provides you, but very much general purpose. Moving a little further up the stack, you start to look at other types of platforms. And then you get into automotive-grade Linux, which provides you something you can run in the car, but is also building an infrastructure on the back end. So all of a sudden, I have automotive-grade Linux, which is building on top of these other foundations that provides the automotive industry something standard to iterate and start to provide products and services on top of. You have drone code, similarly doing the same sort of thing. It started out as let's write code for drones. Now it's starting to talk about how do we handle information flow from the drones back to a central center and create that addressable platform for applications to build on top of. And EdgeX, a new initiative which is recently launched, doing the same thing, looking at, originally started off, how does this device talk to a back-end system? That was where it began. And then it's moving into how does that back-end system look, what do we expect from the devices, and how do we build a platform that can then be leveraged for a broader array of IoT-type scenarios. And this is the landscape that we exist in. And we sit here in OpenStack and we get this requirement and that requirement and a bunch of stuff coming in, people talking to us about 100 different things. And it's really hard to map it. I have a tiny little map here of a corner of the world. I've tried to make it broad, but it's still a very small portion of the people that require some sort of an open infrastructure. And that's where OpenStack comes in. OpenStack, the Open Infrastructure Project, OpenStack being able to provide infrastructure as a service to a variety of consumers addressing a variety of different needs. From a telecommunications perspective, I mean, we have our needs. We also recognize that our needs are not the only needs, and that's why we come to OpenStack, because we know that OpenStack is the place where we can have our conversations alongside the drone code guys who need their platform running somewhere as well. The cloud native guys who want to figure out, is there value in trying to run our cloud native over infrastructure as a service across a network, and how do we make that happen? So from that perspective, the open infrastructure piece is what we really are looking at from OpenStack. How do we get a ubiquitous, standard, flexible infrastructure layer that we can leverage, we can iterate over, and we can innovate on? So from the edge cloud perspective, it's not a data center. It's generally constrained. It's not, you can't just scale out. You have a limited footprint to deal with. You generally have an opinionated footprint. It's not just a general compute platform. There is often embedded code and often embedded functions associated with it. But as much as possible, it should be standard, it should be flexible, it should be ubiquitous. How does OpenStack play in? OpenStack doesn't have to run as OpenStack everywhere. OpenStack has to figure out, what do I expose in these different parts of the network? What capabilities are required in order for operations to be able to deploy and work with workloads and manage those devices? So what we're looking for from OpenStack is modularity. We want to be able to use the parts that we need. We don't necessarily take the whole thing at once. This is something the foundation team, the community as such, has been working on a lot and making great progress with, so extremely good on that front. It creates an environment where OpenStack can be used in these types of purposes that it wasn't originally envisioned for. Composable, again, being able to pull things out, being able to, for instance, swap out one thing for another. Storage backends, you can say, absolutely, that's the type of model we need to see. Not everything's as simple as a storage backend. Not everything's as complex either. But there will, of course, be deviations on a theme that we need to look at through the composition of edge clouds and how we integrate that infrastructure. And flexible. Flexibility is going to be a key. On my previous slide, you saw a tiny sample of the types of use cases we'll be addressing. It's not that we can even guess what future use cases are coming our way. But what we need from OpenStack is the flexibility, is the modularity, is the composability, that it can be used in different contexts, that it can work with other community software, that we can take the parts that make sense and essentially start to address how we create a ubiquitous end-to-end infrastructure as a service layer. And that, I think, is more or less all I have to say. Kandan, do you want to add anything towards the end?
No, I think this is pretty good. Thank you. And I think we can take like a few questions. And this gentleman had a question.
So, I used to work for Brocade, and before we got blown up by Broadcom, but thankfully, the network spun out of that business, and they're doing pretty much VNF orchestration themselves. But what I was interested to know, OpenStack came with Taka, Glue, and more recently Gluon. Are those components not suitable for VNF deployment for you guys, that you've seen, and not the code's not mature enough, or it doesn't fit the use case, or in terms of orchestration?
So the question, in case you didn't hear, is Taka and Gluon are new NFV-related projects which have come into the OpenStack community, and the question is, are they good enough? I guess.
The answer is yes.
I guess not. That's why you're giving the prezzo, right?
Well,
Okay, I can cover that. So there is really a two aspect, right? One is the components what you're talking about can be deployed in the data center, can be deployed in the edge. I think it's really the additional requirements, right? The additional requirement is like a large scale. Then you also got other zero-touch provisioning because we're talking about large scale. Yeah, so there's additional use cases coming up, right? So that's what the emphasizes, that what we got is very good for the data center, and there's some improvement we had to do. But in terms of the edge, it having an additional requirement, so we do have to address those things.
Because I guess the way that I was looking at it is a product that we're working on at the moment, and I guess this is your utopia as well, is like an office in a box. And we always talk about service chaining in a single off-the-shelf x86, and I think Supermicro has made that possible with the E-series Xeon Ds basically to a price point that's acceptable to the customer. And then it's a matter of, okay, how do you manage the hardware, how do you manage the software, and then how do you manage the service chaining? And that becomes a very complex discussion, particularly when you've got SD-WAN vendors that try and sell you their appliance along with the software for 3 times the price that you could just buy the license plus the white box for. How do you then manage that VNF at the edge?
I think the key is actually.
Can you repeat the question?
Okay, so the question is actually, what about the complexity usually comes along with the VNF in terms of service chaining, in terms of other requirements around SDN?
The hardware and also the VNF.
The hardware, yeah. How do we address that in edge? The the answer really comes down to is that when we try to deploy something prescriptive and simple in the edge location, we do have to be mindful of that, how much complexity we want to package into, okay? And we also have to think about, like, do we want to vary and do we want to create a variation, like, too much from the data center? So in my opinion, actually, it is really a balance about, like, how much we can package it up from a complexity perspective and how much, like, we can manage it from the difference perspective. But it really comes down to is like, like whatever the use case we are trying to, like address, right? As long as it fits into the edge and as long as you can support in the edge, I think it's good. But we do have to keep in mind that the simplicity is very important. I think if you have additional questions, we can follow up because I want to give opportunity.
I didn't want to interrupt and take away from anybody else's time, but just to follow up on what you just said, is that pretty much every SD-WAN solution out there has a central orchestrator located where? The data center. It's a simple edge that can make a quick decision because it can't go backwards into latency, and that's basically what the suggestion is that you're making.
Yes, yeah. So we can follow up after this one. Anybody has any other question, please? You got to speak a little louder. Sorry, it's a big conference room.
I started with ONAP in the edge, and also there will be ONAP in the data center. The interconnect between this edge and data center of the ONAP, and also for the ONAP in the edge, is that simplified version or is a full version of the ONAP?
I think ONAP can sit in the central location, and it can actually manage the central location as well as the edge location. Because ONAP is more in the Uber orchestration layer, and it doesn't need to be put on like every edge location. As we said, the complexity goes like heavily into each of the data center where the edge is going to be deployed, then it's very hard to manage. And that's where that flexibility comes up with the ONAP is that you can actually deploy in a central location and manage like a multiple edge location as well as the data center.
But let me add one thing to that. I think one of the solution or one of the problems that the industry has not solved yet is that if you have tens of thousands of edge locations, how do you have a management structure that would be centralized and still being able to manage this many locations? Or should it be an individually kind of distributed, or will there be a parent-child relationship? So those are some of the things that the industry and the community needs to address. And these are some of the requirements that Kandan mentioned, that in terms of the slim down and the zero-touch aspects of it that needs to be addressed.
I think that's a good point. The balance between federation and distribution as you get closer to the edge starts to shift, and at some point you'll be applying a different technology depending on whether you're federating towards something which can act in an autonomous manner or if you're starting to distribute and more dictate towards the workload.
AT&T took the VIS architecture, right? The exchange becomes the point where they did virtualization.
Yeah, the VCO stuff, yeah. And that's as of today, because you don't have anything further out at this point. And the question is, does that model change as well as we move forward? But
All right, guys, we are running out of time.
are we?
Right,
Okay.
yeah. Thank you
There's
very much.
one other question. Let's
I
see.
think we can follow up after the thing. All right, thank you very much,
All
guys.
right, thank you.
All right.